Introduction to optimistic rollups. Optimistic rollups are a popular layer 2 scaling solution for blockchains. They offer a significant improvement in scalability and cost effectiveness, addressing the inherent limitations of blockchain technology. Optimistic rollups are based on the principle of optimistic execution, where transactions are assumed to be valid and are only challenged if proven otherwise. Optimistic rollups enhance the scalability of blockchains by processing transactions off chain and then submitting only the transaction results on the main chain. This allows for a significant increase in the transaction throughput without compromising the security of the main chain. The optimistic part refers to the assumption that all transactions are valid, and only in cases of fraud or disputes are they challenged and then verified on the main chain. This approach results in faster transaction confirmation times and lower costs for users. So now let's see how optimistic rollups work. Optimistic rollups are a novel approach to scaling blockchains. They operate by processing transactions off-chain, leveraging a network of nodes to execute transactions in a fast and efficient manner. This off-chain execution allows for a significant increase in transaction throughput, reducing the strain on the main blockchain. A crucial aspect of optimistic rollups is the assumption of transaction validity. Transactions are considered valid unless they are challenged and proven otherwise. This approach relies on a mechanism known as fraud proofs. If a dispute arises, a fraud proof is submitted to the main chain, which triggers a validation process, ensuring the integrity of the rollup. Let's talk about the key components of optimistic rollups. First are sequences. Sequences play a crucial role in optimistic rollups, handling the ordering and execution of transactions. They act as intermediaries, accepting transactions from users and bundling them into batches before submitting them to the rollup contract. Sequences are responsible for ensuring the efficient and timely processing of transactions within the optimistic rollup system. Fraud proofs. Fraud proofs are a critical component of optimistic rollups, serving as a mechanism for verifying the integrity of transactions. In the event of a dispute or a challenge, a fraud proof is generated and submitted on the main chain. This proof allows for verification of the transaction's validity, ensuring that the rollup operates in a secure and transparent manner. Rollup contracts. Rollup contracts are smart contracts deployed on the main chain, responsible for managing and verifying the state of the optimistic rollup. They receive the aggregated transaction results from the sequencer and validate them against the fraud proofs. Rollup contracts are essential for maintaining the integrity of the optimistic rollup system and ensuring that all transactions are executed correctly. Let's talk about the role of sequencers. First, transaction collection. Sequencers play a vital role in optimistic rollups by collecting and ordering transactions from users. They act as a central point where transactions are submitted and prepared for processing. Batching and execution. Once transactions are collected, sequencers bundle them into batches for efficient processing. These batches are then executed off chain, leveraging a network of nodes to ensure fast and cost effective execution. Finally, submission to the main chain. The results of these off-chain transactions are then submitted to the main chain for verification. Sequencers ensure that the transactions are submitted in a timely manner, maintaining the smooth flow of operations within the optimistic rollup system. Let's talk about fraud proofs mechanism. Fraud proofs are a crucial component of optimistic rollups, allowing users to challenge potentially invalid transactions. This mechanism ensures the integrity of the system and protects users from malicious actors. Fraud proofs play a vital role in maintaining the security and trust within the optimistic rollup ecosystem. Challenge period. After a transaction is submitted, there is a designated time window during which users can challenge its validity. If a user believes that a transaction is invalid, they can submit a fraud proof to the main chain. Submitting fraud proofs. The process of submitting a fraud proof requires users to provide verifiable evidence that the transaction in question is indeed invalid. This evidence can include details of the transaction itself, the state of the rollup, or other relevant information. Finally, on-chain dispute resolution. Once a fraud proof is submitted, it is validated on the main chain. If the proof is verified, the challenge transaction is reverted, ensuring that the rollup state remains consistent and secure. If a fraud proof is invalid, the challenger is penalized. This mechanism provides a robust solution for dispute resolution, ensuring that optimistic rollups maintain their integrity and operate in a secure and reliable manner. Next, roll-up contracts. Transaction data storage. Roll-up contracts are responsible for storing transaction data from the roll-up chain. They act as a central repository for all the transactions that occur on the layer 2 chain. This data is essential for verifying the integrity of the roll-up and for resolving disputes. Deposit and withdrawal management. Roll-up contracts facilitate the movement of assets between the layer 1 main chain and the layer 2 roll-up chain. Users can deposit assets into the rollup contract to participate in the layer 2 ecosystem. When users want to withdraw their assets, they can do so through the rollup contract, ensuring a secure and reliable transfer of funds. Security and validity. Rollup contracts play a vital role in maintaining the security and validity of the rollup system. They verify the results of transactions submitted from the sequencer and ensure that the rollup state remains consistent with the main chain. This verification process helps prevent fraud and maintain the integrity of the system. Let's talk about the benefits of optimistic rollups. First, increased scalability. Optimistic rollups enhance the scalability of blockchains by processing transactions off-chain. This allows for a significant increase in transaction throughput without compromising the security of the main chain. The ability to handle a larger volume of transactions makes optimistic rollups a powerful solution for addressing blockchain scalability challenges. Next, lower transaction costs. By offloading transaction processing to a network of nodes, optimistic rollups significantly reduce the cost associated with transactions. This cost reduction is achieved by minimizing the computation and storage requirements on the main chain. Optimistic rollups make blockchain technology more lowering the barrier to entry for users. And finally, obviously, improved user experience. Optimistic rollups offer a smoother and more efficient user experience by reducing transaction confirmation times. Leads to faster and more reliable interactions within the blockchain ecosystem. The faster transaction speed and lower costs create a more positive and engaging user experience. Scalability. Offloading transactions. Optimistic rollup significantly increase throughput by moving transaction processing off-chain. Optimistic rollups can handle a much higher volume of transactions per second. This significantly increases transaction throughput, allowing for faster transaction confirmation times and a more efficient user experience. Reduced transaction costs. Reduced gas fees. Optimistic rollups significantly reduce gas fees for users. Transactions are processed off-chain, minimizing the computational burden on the main chain. This translates to lower fees for users, making blockchain interactions more affordable and accessible. Affordable transactions. Lower transaction costs empower users with greater flexibility and affordability. With reduced gas fees, users can participate in the blockchain ecosystem without facing prohibitively high transaction costs. This fosters greater adoption and participation, driving the growth and development of the blockchain space. Faster transactions. Quicker confirmation. Transactions processed via optimistic rollups are confirmed much faster than those on the main chain. This is because transactions are batched and executed off chain, reducing the wait time for users. The fast confirmation times allow for a more efficient and responsive user experience, making optimistic rollups an attractive solution for applications requiring quick transaction finality. Reduced waiting times. Users no longer need to wait extended periods for the transactions to be confirmed. The faster transaction speeds provide a significant improvement in user experience, allowing users to interact with the blockchain network more seamlessly. This reduced wait time also allows for the development of more dynamic and interactive applications that can leverage the fast transaction processing capabilities of optimistic rollouts. Enhance security. Security through main chain settlement. Optimistic rollups leverage the security of the underlying main chain. Transactions are eventually settled on the main chain, providing a strong security guarantee. The rollup contract on the main chain verifies the validity of ensuring that only legitimate transactions are confirmed. Fraud-proof mechanism. Optimistic rollups implement a fraud-proof mechanism to address potential disputes. If a user suspects a transaction is fraudulent, they can submit a fraud proof to the main chain. If the fraud proof is valid, the transaction is reverted, preventing malicious actors from manipulating the system. Privacy benefits. Off-chain transaction privacy. While optimistic rollups are not primarily designed for privacy, they offer some benefits in this regard. The off-chain nature of transaction processing in optimistic rollups mean that transactions are not directly visible on the main chain. Potential for privacy enhancements. Optimistic rollups can potentially be integrated with privacy enhancing technologies. This could involve using techniques like zero knowledge proofs or homomorphic encryption to further enhance the privacy of transactions processed within the rollup system. Let's talk about an example like Arbitrum. So, first is Ethereum integration, right? Arbitrum is a layer 2 scaling solution that seamlessly integrates with the Ethereum mainnet. This allows users to access the Ethereum ecosystem while enjoying the benefits of faster transactions and lower fees. Next is faster transactions. Arbitrum optimizes transaction speeds by processing them off chain in batches, which greatly reduces the time it takes for transactions to be confirmed. Next are reduced transaction costs. With transactions being executed off-chain, Arbitrum significantly lowers the gas fees associated with Ethereum transactions, making it more affordable to interact with the network. Finally, enhance security. Arbitrum prioritizes security by leveraging the security of the Ethereum mainnet. All transactions are ultimately settled on the main chain, providing a strong security guarantee. Let's take an example code, which is a simple rollup contract. So the code snippet will demonstrate a basic rollup contract written in Solidity. It will outline essential functionalities like deposit and withdrawal, showcasing the core principles of managing assets within a rollup system. The simple contract will serve as an introductory example to illustrate the concept of how rollups handle transactions and manage user balances. Okay, so let's go through each and every line of the code, right? So first here, this Pragma Solidity 0.8.0 specifies the Solidity compiler version to use. Then you're declaring a contract called simple roller. Then you're declaring a state variable called balances. It's a mapping from addresses to unsigned integers, u in 256. It tracks the ether balance of each user essentially, and public keyword generates a getter function. Get, but public keyword generates a getter function automatically. Let's talk about the events next. So we're declaring two events. First is deposit. The second is withdrawal. Deposit logs when a user deposits ether. Withdrawal logs when a user withdraws ether. Indexed keyword allows searching for these events by user addresses. Deposit function. Okay, so what this does is it allows users to deposit ether into the contract. Public keyword makes the function callable by anyone. Keyword allows the function to receive ether. Message.sender is the address of the caller. Message.value is the amount of ether sent with the call. And yeah, it updates the caller's balance in the balances mapping. And finally, it emits a deposit event with the caller's address and the deposited amount. Then you have your withdraw function. Finally, this allows users to withdraw ether from the contract. Public keyword makes the function callable by anyone. Takes an amount parameter specifying how much ether to withdraw. Require statement checks that the caller has enough balance essentially, and then it updates the caller's balance in the balances mapping, transfers the specified amount of ether to the caller, and it emits a withdrawal event with the caller's address and the withdrawn amount. Yeah, okay, so this is the code. So let's see how to use optimistic rollups. So first you set up a wallet, create a compatible wallet to interact with the optimistic rollup network. Popular options include MetaMask, Coinbase wallet, or other Web3 wallets. Then you connect to network, connect your wallet to the specific optimistic rollup network you want to use. This involves adding the network to your wallet settings. After that you initiate transactions. Send transactions like deposits or withdrawals using your connected wallet. Transactions are processed off-chain and settled on the main chain later. Next, you interact with dApps, explore decentralized applications built on the optimistic rollup network, accessing their features and services. Next are development tools and frameworks. First is Optimism SDK. The Optimism SDK is a comprehensive toolkit for developers building on the Optimism network. It provides a streamlined way to interact with the Optimism chain, including tools for contract deployment, transaction management, and account abstraction. Next is Arbitrum SDK. Similarly, the Arbitrum SDK offers a set of resources for developers building. It simplifies the process of interacting with the Arbitrum network, making it easier to develop applications and deploy contracts on the Arbitrum chain. Let's talk about other tools. So, beyond the SDKs, various development tools and frameworks can be leveraged for building an optimistic rollup. These include popular blockchain development tools like Truffle, Hardhat, and Remix, which offer features like contract compilation, testing, and deployment. Then let's talk about integration with existing tools. So it's important to note that these tools are often integrated with existing development workflows, allowing developers to leverage their existing knowledge and skill sets. This integration ensures a smooth transition for developers accustomed to building on traditional Ethereum development environments. Let's talk about a few challenges of optimistic rollups. So first are security concerns. Optimistic rollups rely on a fraud-proof mechanism for security. This mechanism relies on users to identify and challenge fraudulent transactions, which can be a burden. Users may be hesitant to submit fraud proofs due to the potential for loss or the complexity involved. User experience issues. Optimistic rollups involve a longer transaction finality time compared to other layer 2 solutions. can be a challenge for users who need faster transaction confirmations, particularly in real time applications. Users may also experience higher latency during periods of high network activity. Complexity of implementation. Implementing optimistic rollups requires specialized knowledge expertise in areas such as cryptography, smart contract development, and consensus mechanisms. This can be a barrier to entry for developers who lack the necessary skills or resources. Let's talk about future developments. Enhanced fraud-proof mechanisms. Research is going to enhance fraud-proof mechanisms in optimistic rollups. This could involve developing more efficient and robust systems for verifying transaction validity. Such advancements aim to strengthen security and reduce the risk of fraudulent activity. Better integration with Layer 1. Future developments will focus on improving the integration of optimistic rollups with Layer 1 blockchains. This could involve streamlining the communication and interaction between the rollup and the main chain, resulting in more efficient and seamless operation. Increased adoption and use cases. As optimistic rollups mature, they are expected to see wider adoption in use cases. More developers and businesses are anticipated to leveraging optimistic rollups to build scalable and cost-effective applications, driving further innovation in the blockchain space. Let's compare optimistic rollups and ZK rollups. Optimistic rollups rely on a fraud-proof mechanism to ensure transaction validity. They assume transactions are valid unless challenged. They're optimistic, right? They have a longer finality time but offer lower development costs. Cut. Optimistic rollups are best suited for applications with moderate transaction throughput requirements and where security and cost effectiveness are prioritized. They are well suited for applications where transaction finality is not a critical concern. ZK rollups. ZK rollups utilize zero knowledge proofs to verify transactions off chain. They achieve faster finality times and higher throughput but require significant computational resources. ZK rollups are thus ideal for applications that demand high transaction speeds and low latency, such as decentralized exchanges or gaming platforms. They are also suitable for applications where privacy and security are paramount. Let's talk about the conclusion and next steps. Optimistic rollups offer a promising solution to the scalability challenges facing blockchain networks. By processing transactions off chain and settling them onto the main chain, optimistic rollups enhance throughput, reduce costs, and improve user experience. We encourage you to delve deeper into the world of optimistic rollups, experiment with different development tools and frameworks, and explore the wide range of applications being built on this technology. Stay informed about the latest advancements in optimistic rollups as the field is constantly evolving and innovating. Thank you very much, and I'll see you on the next